We're going to talk about nuclear fission. Nuclear fission is actually what happens in nuclear power plants when we're actually gaining energy and we're talking about nuclear reactions. That's when we split the nucleus into fragments. And why do we do that? So let's look at this graph. This graph on the y-axis is binding energy, on the x-axis has mass number. And just a heads up, binding energy is the energy needed to break up 1 mole of nuclei into its individual nucleons, or individual particles, protons and neutrons. So for low mass numbers down here, they actually are. Doesn't take a lot of energy for us to break apart into other separate parts. Up here also doesn't. As you get to higher mass numbers, it doesn't take as much energy also to break itself up into separate parts. So the most stable, as that we found through many experiments, is that the mass number is close to 60. 60 mass number actually has the most stable nucleus. It takes a lot of energy for us to mess with it and break it apart and do things with it. So all atoms are trying to get to the point where they have a mass number of 60. So things over here are going to break down. Things with higher mass numbers are going to break down. Things with lower mass numbers are going to start fusing together. That's fusion, and we'll talk about that another time. Okay, so uranium is actually what's typically used when dealing with nuclear fission and power plants. So what we do is we bombard uranium with high-speed neutrons. What that does, it gets it to a very, very unstable nucleus, and so it's able to break down much quicker. This has a half-life of a couple million years. This actually has a half-life that's much faster. So then what this does, it spontaneously breaks down into these products, krypton, barium, and then more neutrons. Okay? These guys are extremely unstable. When we're talking about nuclear waste, it's because these guys are produced, krypton and barium. These guys are nuclear waste that are very unstable. They'll continue to decay, giving off lots of energy, giving off lots of bad things in the environment. So this is when you're talking about having to be nervous about nuclear energy. It's because these byproducts are present. Now, when this reaction, this is very, very unstable, so it has a lot of energy within the nucleus. So when it breaks down, it's going to explode and not explode necessarily, but give off a lot of energy, and it's going to heat up water, things like that, give off a lot of energy, and we're able to harness that energy to use things for, power, fuel, our resources. So what it then does is it gives off another product of this reaction is 3 neutrons. And so what happens with these 3 neutrons, they then can start the reaction over again and bond with the uranium atom, and then so on and so forth. If we have enough uranium atoms, we call that a critical mass. That means that a reaction can continue and continue and continue without us having to do anything to it. So this is actually basically the basic component of how nuclear reactions or nuclear power plants work. Essentially, it's breaking down uranium atoms and giving off a lot of energy and being able to harness that energy for use in other places. So this is essentially what nuclear fission is.